What is 0 to the power of 0? Now it might sound weird because how can you multiply 0 by itself a zero number of times? For example, 2 to the power of 3 is 2 multiplied by itself 3 times. But then how do you multiply 0 times? Well, through the laws of exponential numbers, we can figure out two laws that help define it. So a to the power of 0 is always equal to 1. We know that just by simple rules. Also, a conflicting rule, though, is 0 to the power of x is always equal to 0. After all, 0 times 0 times 0 an infinite number of times. It's always equal to 0. However, if you look back up, these two rules are conflicting. One says that this should be 1, and the other one says that this should be 0. So we're trying to find what 0 to the power of 0 is today. Well, it turns out we can actually define this as a function, x to the power of x. After all, if we plug in x equals 0 into this equation, we actually end up getting 0 to the power of 0. Now, if you see where I'm leading here, if we find a limit of this function as x approaches 0, we'll actually, in effect, get what the value of 0 to the power of 0 is. And we know it has to be either 1 or 0 by the two rules that are conflicting in this equation. So let's start plugging in numbers here because as we can see, if we plug in numbers that slowly go down to 0, we can actually find a limit. And if we see which one it's going to, 1 or 0, we can find the answer to 0 to the power of 0. So let's start plugging in numbers. 1 to the power of 1 equal to 1. Now if I plugged in 0.9 to the power of 0.9, after all, these numbers have to be the same because 0 and 0 are the same. And it wouldn't make sense to do like 0.9 to the power of 0.8 because it's the function that we're defining is x to the power of x. So this equals to 0.9095. So it seems like we're going away from 1 right now. So 0.8 to the power of 0.8, 0.8365. Once again, it seems like we're going down to 0. 0.7 to the power of 0.7 is equal to 0.7791. So we're dropping. 0.6 to the power of 0.6 is equal to 0.7360. So it seems like we're slowly getting down to the number that we want to get. 0.5 to the power of 0.5 is 0.7071. 0.4 to the power of 0.4 is equal to 0.6931. So all of these numbers are descending. So let's keep plugging in numbers. 0.3 to the power of 0.3 is equal to 0.6968. Wait, that's weird. We're starting to go up all of a sudden. So could the limit actually be at 1? Let's keep plugging in numbers to find out. 0.2 is equal to 0.7248. So we made a huge jump here. So if we plug in 0.1, 0.1 equals 0.7943. Now I'm just going to do 1 out of curiosity because this will truly help us find the limit. How about, let's do 4 zeros. So if I plug this onto my calculator, 0.00001 to the power of 0.00001 is equal to 0.999848774. So as we can see, the limit is definitely getting equal to 1, which means since 0 to the power of 0 is defined in this function, then 0 to the power of 0 must equal 1.